Hello.
Hello, sir.
Hey guys, I'm so sorry I got a bit late today. Got stuck at work. Ah, 1 second, guys. Let me share my screen. Just give me 1 minute. We're gonna get started with the session. Anyone who has joined the session for the first time today? Anyone who hasn't joined the sessions earlier, and this is your first class, by any chance? 3, 4, 5. Oh, okay. Assuming no one. In the last class, guys, okay, perfect. So I guess everyone is here. Let's get started without any further ado. What did we discuss in the last session, guys? What was the last topic that we covered in the session yesterday? I think we talked about what networking is, what networks are, what are hosts. We also covered what IPv4 addresses are, what the properties of an IPv4 address are, and how do you calculate the range of IP addresses? What's the first IP? What's the last IP? What is the sequence of IPs? Okay. And then we also talked about the difference in these classes. Okay. What are these public IPs, private IPs, etc., etc. Today we're going to talk about the relevance of these classes and their ranges, right? Someone in the session yesterday asked me about these classes and all. Is that student still present here today? Who asked me about classes yesterday, guys? Someone among you asked about classes yesterday. Can't recall exactly. But okay, anyways, so as mentioned, your entire IPv4 range of addresses are divided in these 5 classes. Class A, Class B, Class C, Class D, and Class E. Class A starts at the first IP, 0000, and Class E ends at the last IP, 255, 255, 255, 255. Here's the first IP, and here's the last IP. 1 second, let me highlight this if possible. Yeah, much better. Okay. As you can notice over here, class A starts at the first IP 0000, and class E ends at the last IP 255, 255, 255, 255. Okay. Now each of these classes has its own unique ranges, guys. Class A starts at 0 and goes up to 127, 255, 255, 255. That's the class A range. And since it's ending at 127 and the remaining 3 octets are 255s, class B naturally starts at 128,000. Okay. So all the 255s cycle back to 0 and the leftmost octet increments by 1. So this 127 changes to 128. That's what we learned in the sequence of IPs yesterday. Okay. And from 128,000, it goes up to 191, 255, 255, 255. Since it's ending at 191, class C starts at 190. From 192,000, it goes up to 223, 255, 255, 255. And since it's ending at 223, class D starts at 224. And from 224, it goes up to 239, 255, 255, 255. Since it's ending at 239, class E starts at 240. And from 240, it goes up to 255, 255, 255, 255. Last time. Okay. So all you have to remember are only these 4 numbers here: 127, 191, 223, and 239. From these 4 numbers, you automatically get the next range. Class A 0 to 127, Class B 128 to 191, Class C 192 to 223, Class D 224 to 239, and Class E 240 to 255. Okay. And again, in each of these classes, you have a set of public IPs and a set of private IPs as well. So in Class A, between 0 and 127, there's a small range, 10,000 to 10,255, 255, 255. That's the private IP range in Class A. Any IP within that range is a private IP, and any IP outside that range is a public IP again. So these ranges and all have been fixed by the people who invented IP addresses, guys. Again, to understand why specifically these numbers, that's a much deeper concept called parity bit. Okay, so again, I can write it down in the chat box. It's called as parity bit value. Okay. But again, if you can get some time, you can do some research on that. Okay. If not, again, frankly speaking, not so required right now. Okay. So again, from those parity bit values itself, you got these ranges actually, these numbers actually. So they're not random. They were calculated from something called parity bit. Okay. So class A from 0 to 127, there's a small range 10,000 to 10,255, 255, 255. That's the class A private IP range. Any IP within that range is a private IP, which can be used in your local network. And any IP outside that range is a public IP, used by the ISPs to provide the internet access. Similarly, in class B also, between 128 and 191, there's a small range, 172.16.00 to 172.31.255.255. That's the private IP range in class B. Any IP within that range is a private IP. Any IP outside that range is a public IP. Similarly, in class C as well, between 192 and 223, there's a small range, 192, 168.00 to 192, 168.255.255. That's the private IP range in class C. Any IP within that range is a private IP. Any IP outside that range is a public IP. And in class D and class C, you don't have any private IPs at all. All of them are public IPs itself. If this is still a bit unclear, and if I had to elaborate on this, let's take the example of class A. So class A, first IP starts at 0000, and it goes up to the last value, 127, 255, 255, 255. That's the entire class A range. In that entire range, there's a small private IP range from 10,000 to 10,255, 255, 255. So that range of IPs is private IPs. And any IP outside that range is a public IP. So from 0 all the way up to 10, which is 9,255, 255, 255. Because after this number, you get 10,000. Okay. And after 10, 255, 255, 255, you have 11. So from 11 up to 127, that's the other public IP set. So there's a small private IP set and two public IP sets, one on each side. So this is the same scenario in every class, guys, A, B, and C as well. Okay. So is that clear? Any questions or doubts up to this point? Anyone?
No, sir.
So if this is clear, guys, what I'm going to do now is I'm going to write down some random IPs. And looking at these ranges, I want you to tell me which IP belongs to which class and whether they are public or private IPs. Okay. So let me quickly write down some IPs here. Hey, Josephine, I hope you can hear me as well. Any questions or doubts? Okay, perfect. Right. So let me just quickly write down some IPs here, guys. 1 second. Yeah. Okay. So I've written down a couple IPs here, guys. Looking at these ranges now in the background, I want you to tell me which IP belongs to which class and whether they are public or private IPs. I hope it's visible, guys. I hope the ranges are visible. I hope the IP addresses are visible. Take your time. So any answers on the first IP? 10.11.12.13. Which class is this? And is it a public IP or a private IP?
Class A private IPC.
Okay, I've got one answer as a public IP and one answer as a private IP. So this is definitely class A. Okay, as you can notice, this for the first octet 10 falls between 0 and 127. So therefore, this is definitely class A. But now, to figure out if this is public or private, we have to look at this range here, right? So for it to be a private IP in class A, first octet should be 10. And the remaining octets can be anything from 0 to 255. For an IP to be a private IP in class B, what's the scenario? First octet should be 172. Second octet should be between 16 and 31. And the remaining two octets can be anything from 0 to 255s. And for class C, similarly, first octet should be 192, second octet should be 168, and third and fourth can be anything from 0 to 255s. Okay. So here we have the first octet as 10 and the remaining octets as numbers from 0 to 255. So therefore, this is a private IP, right? So whoever mentioned public, I hope it's clear for you that this is a private IP, guys. Okay. Moving on, next one, 172, 35, 45, 55. Which class? And public or private?
Class B.
Class B, perfect answer. Public or private, guys?
Private. Sir.
Are you sure, Muktesh? Is it private? First octet is 172. That seems to match. But the second octet is 35, which is not between 16 and 31. So therefore, this is a public IP, right? Tish.
Okay, sir.
Okay, guys, can you hear me now? For some reason, we got disconnected for a while. I hope I'm audible.
Sir, yeah.
Yes. Yes.
Oh, my voice is not audible.
No, it's audible.
It's audible, right? Perfect. Perfect. Right. Next answer, guys. 192, 167, 168, 169. This is class C, but public or private? Okay, I've got one answer as
Public.
private and one answer as public. Let's see.
Public.
So the first octet is 192. That seems to match, but the second octet should be 168 for it to be classified as private. But here we have 167, if you notice. So therefore, this is a public IP, guys. Okay. So please be careful about the ranges, guys. You have to look at every octet. Okay. Moving on, next one. So 42, 150, 192, 41. Which class and public or private?
Class A public.
Class A, perfect. Public or private?
Public, sir.
Public, correct answer. Next one. Class B, perfect answer.
Class B public.
And public, correct
Public,
answer. Next one. 170, 180, 190, 200.
Class B public, sir.
Class B and public, correct answer. Next one. 20, 30, 40, 50. Class A.
Public.
Public. Correct answer. Next one.
Class C private.
Okay, I've got one answer as
Class public.
private and one answer
Public.
as public. Yeah, if you notice, 169 is falling outside the range. So therefore, this is a public IP. Okay. Next one. Class B.
Private.
Private.
Perfect answer. Private. Correct. Let's say 222, 240. Last few numbers. 220, 230, 40, 50.
Class C
Class
public.
C public.
Class C and public. Correct. Next one.
Class C, sir.
Class C. And public or private.
Public.
Perfect.
Public.
Next one.
That's not so. Class D, sir.
Class B, are you sure?
It is, sir.
D, yeah. And D, public or
Class
private?
D. D public.
Public. Correct
Public.
answer. Okay. So again, perfect answers, guys. Some mistakes here and there, that's completely okay. Okay, but again, as mentioned, what we have done today is we have looked at these ranges and we have tried to figure it out. But I would recommend you remember these ranges, okay? Because as soon as you look at an IP, you have to figure out which class it belongs to and whether it's a public IP or a private IP, okay? From that, you can understand where the attack is coming from. Okay? If it's a private IP, if in the logs, if you see the attack is coming from a private IP, it means the device is in your own same network. It's in your own local home network, Wi-Fi network, or in your organization. Okay. If it's a public IP, it means the packet is coming from an external network that's coming from the internet, which means the attacker is somewhere, anywhere on the internet, not in your network. Okay. So that can only be understood if you remember these ranges. Okay. And in the last class, I've shown you how do you check your public IP and how do you check your private IP, right? So if I had to check my public IP, I can go to my browser here. And in my browser, I could just do a quick search. What is my IP? And this shows me my public IP here. 49, 204, 239, 220. Looking at this IP, can you tell me which class it belongs to, guys? 49, 204, 239, 220. Which class is this?
Class A.
Class A, sir.
Class A.
Perfect. And is it falling in the public IP range?
Yes, sir.
Yes, it's public.
Yeah, it's a public IP. So if you notice, it's not inside the private IP range. Hence, it's a public IP. And if I had to check my private IP on the other hand, I can run a command called ipconfig in my command prompt. So if I type ipconfig here, I get a private IP as you notice. And I'm getting the IP here, 192.168.0.3. That's my IPv4 address. Looking at that address, can you tell me if it's a private IP or not? Can you confirm?
Private IP with class C.
Yes, it's a private
Class
IP
C, sir.
that belongs over here in class C, if you notice. Okay. So that's how you can figure out which IP is public and which IP is private. But now the main question that arises here is why 5 separate classes? Why not just one single class with some public and private IPs in it? So the answer to that is, guys, again, every network requirement is different. So what network I have at my home, in my local home Wi-Fi network here, and what network that could exist in an organization, in an MNC, could vary in a very large numbers. Okay. So the network requirements in an MNC and the network requirement in my home will differ very differently. Okay. So the difference over here is the network sizes. Okay. To elaborate on this, you have to remember each class has a different network portion number and a host portion number. So class A has only one network portion and 3 host portions. Class B has 2 network portions and 2 host portions. Class C has 3 network portions and 1 host portion. and class D and class E have all network portions itself. There are no host portions in it. So as you're going down the line, class A has one network portion, class B has two network portions, class C has three network portions, class D and class E have four network portions. So as you're going down the line, network portions are increasing and the host portions are decreasing. Okay. But what do I mean by these network portions and host portions? What do they signify? Let's talk about that. So to understand this, we'll take the example of class C first. Okay. And where does class C private IP begin, guys? The class C's private IP starts at 192.168.0.0. Okay, that's the first private IP in class C. Okay. So now I'll write down the same IP now in a textpad file. So just a second. Let me open up a textpad file here. So we all know private IP for class C starts at 192.168.0.0. That's the same thing which I've written down here. Okay. And in class C, there are three network portions and only one host portion. Okay. Now, according to the sequence of IPs, guys, if 192.168.0.0 is the first IP, what was the next IP be? 0.1. Next IP, 0.2. Next IP, 0.3. Next IP, 0.4. This goes on all the way up to the value 0.255. Okay. And once you reach 0.255, what happens after that? This 255 cycles back to 0. And this 0 here changes to 1. Okay. Now, what I mean by network and host portions is, as long as the host portion changes, it signifies a change in the host only. So this could be my Wi-Fi router. This could be my mobile phone. This could be my laptop. This could be my smartwatch. As such, I can connect a maximum of up to 255 devices. Okay. But when I go to the next IP here, when this 0 now changes to 1, the network divides over here. So whenever there's a change in the network portion, that signifies a change in the network altogether, which means these devices belong to one single network and these devices belong to a completely separate network. Okay. And they cannot communicate with each other. Devices belonging to the same network only can communicate with each other. So the 0.1 can only communicate with all the other devices in the same network. Okay. Similarly, 0.2 can communicate with the devices in the same network, but it cannot communicate with other networks. Okay. So that's what the network portion and the host portion signifies, guys. Host portion indicates the host in the network, and network portion indicates the identity for the entire list of devices or the list of hosts in that network. Okay. So from 192.168.0.0 to 0.255, that's the first network. From 10 to 1255, that's the next network. 20 to 2255, that's the next network. 30 to 3255, that's the next network. Okay. So as such, in each class C network, we can connect a maximum of only 255 devices, not more than that. So in my home network, I don't have a requirement of connecting more than 255 devices. I hardly have 5 or 6 devices, not more than that. So for that, I can use class C in my home network. And that's why, if you notice, I'm getting the IP here as 192.168.0. something. Okay, that indicates that this is a class C network. And in my network, I can connect a maximum of 255 devices, not more than that. Okay. Is that clear, everyone? Raja, Vinay, Mukesh, Guru Datta,
Yes, sir.
Praneeth, Shivasai.
Yeah.
Right.
Yes, sir. It's
Yes,
clear.
sir.
Right. Moving on to the next class now. When you talk about class B, there's two network portions and two host portions here now. Okay. So now, you all must have known now that class B private IP starts at 172.16.0.0. Okay. That's the first private IP in class B. First two portions are the network portions. Last two portions are the host portions. Okay. So after 00, you have 01, 02, 03, 04, goes up to 0255. Okay. Then you have 10. Now, please note the network doesn't divide here. Both these portions are host portions itself. Okay. So after 0255, this device can communicate with the next IP 10 also because they are both host portions only. So after 10, you have 11, 12, 13, 14, 15, 16, goes up to 1255. Then 20, 21, 22, 23, 24, 25, which goes up to 2255. Like that, the cycle keeps on repeating. And somewhere down the line, you'll have 2550, 2551, 2552, 2553, which goes up to 255, 255. Once both these octets are filled, now this 16 changes to 7. Okay. Same logic, as long as the host portions are changing, it just indicates a change in the host, a change in the device. All of them still belong to the same network. But when the network portion changes, when the 16 changes to 17, the network divides over there. And here starts a new network. So from 1700 to 17255255, that's a separate network. 1800 to 18255 next network. 1900 to 19255 next network. Okay. Like that, it goes on all the way up to 31000 to 3125525. That's the last private IP in class B. Okay. Now, from this, we can understand that in each class B network, since you have two host portions, you can connect a maximum of 255 into 255 devices. So in class C, we could only connect 255 devices. But in class B, we can connect 255 into 255, which is equal to 65,535 devices in each network. Okay. So for MNCs, for large companies or organizations, where you have a requirement of connecting more than 255 devices in each network, there you go for class B. Class C is not useful there. You have to go for class B. Okay. And similarly, when you come to class A, it has one network portion and three host portions. So all the way from 10,000 to 10,255, it belongs to one single network. And you can connect here a maximum of 255 into 255 into 255 devices, a much larger network. Okay. So each class here signifies how many devices you can connect in each network, guys. Class C, only 255 devices. Class B, 255 into 255 devices. And class A, finally, 255 into 255 into 255 devices. Much larger network. Logically speaking, this is possible, guys. In practicality, it's not. Okay. But this is what the significance of each class is. Okay. Is that clear for everyone? Muktesh, Guru Datta, Praneeth, Shivasai,
Yes,
Yes,
and
sir.
it's clear.
Doti, Raja Vinay. Right. Okay. Last concept for today. What is subnet mask? Okay. So when we check our private IP here in my command prompt, when I run ipconfig, you can see along with my IP, I see something called subnet mask and something called default gateway. So this subnet mask is for the computer to understand which IP belongs to which class, guys. So for us humans, we know which IP belongs to which class with the network and host portions. Class A has one network portion, class B has two network portions, class C has three network portions. But how does a computer understand that? Okay. So for the computer to understand what is the difference between network and host portion, it assigns that network portion with the value of 1 and host portion with the value of 0. Okay. So for class A, where there's one network portion and three host portions, subnet mask is calculated by putting all ones in the network portion and all zeros in the host portions. And when you convert that, all ones is 255 and all zeros is simply 0. So for class A, with the one network portion and three host portions, subnet mask is 255000. For class B with two network portions and two host portions, subnet mask is 255 And for class C with three network portions and one host portion, subnet mask is 255 So when my computer sees this subnet mask as 255 it understands that this is a class C address. And when it knows it's class C, it knows that it can connect a maximum of 255 devices, not more than that. So from that subnet mask, the computer understands what the range of its network is, what's the first IP, what's the last IP, and which class it belongs to. Okay, so that's what the purpose of subnet mask is, for a computer to know what its range of its network is and which class the IP belongs to. Okay, and then you have something called default gateway. This is basically a fancy name given to your Wi-Fi router. Okay, so the Wi-Fi router in your network or any router in your network is called the default gateway. Why is it called the default gateway again? If you look at this diagram here, whenever any of my devices in my home wants to communicate with the internet, all of them will have to send the packet to the router here. So this router is acting as a gateway between the private network and the public network. So whenever any device wants to communicate with the internet, by default, it has to send the packet to this gateway here. Hence the name default gateway, acting as a gateway between two different networks, private and the public network. Okay. And usually your router gets the first IP in the network, 192.168.0.1. Okay. So that's why it's called default gateway. Okay. Is that clear, everyone? What is subnet mask and what is default gateway? Raja Vinay, Muktesh,
Yes, sir.
Guru
Yes,
Datta,
sir.
Shivasai. Perfect. Okay. So yeah, that's that. Nothing further for the session today, guys. This is part 2 of networking. Tomorrow we're gonna have the last part on networking. So tomorrow we'll talk about what are these protocols. How do you assign a private IP? Okay. What is the method to assign an IP manually? How do you get it automatically from a DHCP server? What's a DHCP server? What's DHCP protocol? What is DNS protocol? Again, what are special IPs? We conclude all this in the session tomorrow. So tomorrow will be the last class for networking prerequisites. And after that, we dive into the practical sessions. Okay. So yeah, that's that. Nothing further for the session today, guys. You can join back tomorrow at the same time at 7 o'clock. Apologies for the delay today, guys. Will not be late tomorrow. Had some urgent work at the office, so I had to stay back late. Apologies for that. But tomorrow we start the session sharp at 7 o'clock. Okay, without any further delay. And yeah, that's it. You can join the session tomorrow at the same time. Bye-bye.
Yes, sir.
Thank you, guys. Bye.
Thank you, sir. Thank you, sir.
Please join the session tomorrow at the same time, guys. Bye-bye.